The earth pressure balance TBM has a cutting wheel which is pressed against the tunnel face by hydraulic cylinders. Inside the cutting wheel, the disc cutters and scraping tool loosen the material. If the earth is unstable, and to stop the tunnel face collapsing or digging too fast, the TBM uses the soil that has already been dug out by the cutting wheel to support the tunnel face. This creates a stable environment for the tunneling to move forward. The tunnel face is continuously monitored by pressure sensors. They check the turning power of the cutting wheel and the screw conveyor, and they also keep track of the material that's been excavated. The material is then taken away on conveyor belts. Once the tunneling phase is done, the cutting wheel and screw conveyor are stopped and the ring building phase starts. A complete tunnel ring consists of several lining segments made of pre-built reinforced concrete. These are made in a special factory above ground. They must match the exact size required and are taken into the tunnel on flatbed rail cars. The concrete segments are fed in by the segment feeder and lifted into place using a vacuum. The hydraulic cylinders are temporarily retracted in order to provide enough space for the new segment. The segments are positioned with millimeter precision and held in place by cylinders before being finally bolted into position. The conical keystone is put in from the front to complete the lining ring. The hydraulic cylinders are extended again to secure the segment into position. During all this work, the people and machines are protected by the shield skin from the saturated ground where water is under pressure. All the readings are displayed on monitors in the central control cabin and fed back to the machine operator. Once each section of ring building is completed, the next tunneling phase can start. The mixshield TBMs dig in a different way to the earth pressure balanced TBM and will be used for tunnelling in waterlogged conditions such as below the Thames. Mixshield TBMs use bentonite, which is a slurry of clay and water, to support the excavation face and act as a suspension medium for excavated material. The excavation chamber is behind the cutting wheel and separated by a submerged wall from the working chamber. The excavation is completely filled with bentonite and the working chamber is approximately 2/3 filled. The two chambers are connected in the form of communicating pipes via an opening in the submerged wall. A filter cake is created ahead of the cutting wheel by pressurizing the bentonite in the working chamber with compressed air. The bentonite penetrates the ground to form a membrane which holds back water. Changes in the soil can be handled by adjusting the pressurization. The dug-out material falls into the excavation chamber. Small grains are dissolved into the bentonite and bigger stones and debris fall to the bottom. Flushing nozzles guarantee smooth removal of the excavated material. The excavated material is pumped through the suction line to the separation plane at the surface. Here, the soil is separated out and removed from the bentonite suspension through a centrifuge, and the clean suspension is transferred back into the slurry circuit. As tunnelling advances, the flexible extension lines are installed to extend the line